For the past 6 weeks, the Wearable Wings project has been stuck because I have not been able to figure out how to proceed. One problem concerns the inertia of the pilot. In order for the wing to accommodate changes in air angle, gusty air, without moving this pilot to adjust, it's better to have the wing alone moving, as in nature. And here I have been stuck in finding how best to achieve this. I need to resolve the forces due to the Kaugis on the center spar, which rotates. The ability to rotate is very important to minimize the inertia effect of the pilot, so that the wing can react very rapidly to changes in atmospheric turbulence. To enhance pitch stability, I thought of incorporating a spring. Here's the pump tube, the air pump tube, and if that's incorporated into resisting the forces from the Kaugis, then I can do it in such a way as to increase stability and control. I've been thinking about this for 6 weeks and trying all sorts of ideas. Now I've finally come to some conclusion. Since November the 20th, I've been filling up my notebooks here, trying to find a way to resolve the forces of the wing in order to proceed. And now here it is. It's the 7th of January. I've almost filled another notebook here. And I finally found an elegant solution. I couldn't imagine it would have taken me so long. So much head scratching to come up with something that is really quite simple. The wing stability and control system needs springs. I'm checking out leaf spring. What I have here is an old ski. And I'm going to measure the deflection of the ski. I also have measured the properties of this leaf spring from a vehicle and an offcut from it, a smaller one of the outer laminations. As a result of all this testing, I'll make a choice of which is the most suitable to use. This is a simulation of the actual loads that are going to be applied to the spring. It's important that I actually mock up the situation and adjust the parameters. I've got a piece of vehicle spring, and from my calculations it looks to have the right properties for the wearable wings spring. And so now I'm applying the loads and measuring the deflection. Then I can adjust length and find out exactly what's required. This is one example of the spreadsheets I did. There's a schematic diagram of the spring and the center spar and the pump tube, and here is the rotation of the spar and the various moments, bending moments, due to the Kaugis. And therefore, with that I can work out the various deflections to see if the spring I have chosen will have the right properties.